So this example, you're running errands all around Western Mass. You need to stop at offices located in Springfield, South Hadley, Chicopee, and Holyoke, starting from Westfield and returning to Westfield. Gas costs $3.45 a gallon. This was written when gas costs were high. And your car gets 25 miles per gallon. So you need to calculate your gas costs using both nearest neighbor out of Westfield and cheapest link. The mileages below are from city center to city center and were measured using Google Maps. So what is happening in this matrix is that you have a complete graph of 1, 2, 3, 4, 5 vertices. Westfield, Springfield, South Hadley, Chicopee, Holyoke. And all of the edges are representing all possible ways to get from one city to another. Okay? And these numbers are representing miles. So from Westfield to South Hadley is 17.2, and South Hadley to Westfield is 17.2. So if we were going to do a nearest neighbor out of Westfield, I would go from Westfield, and these stars, by the way, are because we can't go from Westfield to Westfield or Springfield to Springfield. So from Westfield, we're going to go to Holyoke. From Holyoke, we're going to go to Chicopee. From Chicopee, we are going to go to Springfield. Ruh-oh, Raggy. And Chicopee to Springfield was 3.9. From Springfield, we can't go to Chicopee. We can't go to Holyoke. We're not going to Westfield. We got to go to South Hadley. So that was from Springfield to South Hadley is 13.5. And then from South Hadley, we arrived back in Westfield after 17.2. So that total amount of miles, I believe, is 46.2. 11.9 plus 5.4 plus 3.9 plus no. 11.9 plus 5.4 plus 3.9 plus 13.5 plus 17.2 equals 51.9 miles. Okay, now if I wanted to do a cheapest link of this, what I like to do when I have these matrices is I will lay out my vertices with no edges so I can keep track of where I've been. I will draw the edges as I go. I just need to erase this so I can draw it in a place where you can see without scrolling down or zooming out. Okay. 1, 2, 3, 4, 5. Westfield, Springfield, South Hadley, Chicopee, Holyoke. Okay, So I look at this whole matrix and I grab the smallest number, which is 3.9, Chicopee to Springfield. So I went Chicopee to Springfield for 3.9. I'm going to cross this out so I don't pick it again. The next cheapest edge I'm going to pick is 5.4, which is Chicopee to Holyoke. I'm going to mark off the 5.4 here. Now, since I've been in and out of Chicopee, everything from Chicopee is done. It's off of my choices. I can't use it. So I scribble that out. Next cheapest, 5.9, Holyoke to South Hadley. I can do that. Cool. Holyoke to South Hadley for 5.9. Cross that out. I'm done with all of Holyoke. We good. So now the next cheapest is Westfield to Springfield. I can do that. Westfield to Springfield, and that is 10.2. Everything's out of Springfield. It's done because we've been in and out of Springfield. Last choice, Westfield to South Hadley, 17.2. All right, we went from Westfield to South Hadley to Holyoke to Chicopee to Springfield back to Westfield, which is totally the way I would go because South Hadley's the furthest, and then I would work my way back. And there's some really quick roads between Westfield and Springfield. So that came up to a total of 3.9 plus 5.4 plus 5.9 plus 10.2 plus 17.2 equals 42.6 miles. I would want to do this one instead of the 51.9 miles. But it also depends on what I needed in times and, other things. It's not as simple as it's defined here. So hopefully that helps illustrate the concepts of what we're doing. Go ahead and try those problem sets, and we'll review. Okay?